This is a VTube laser and FARO ARM demo showing how to reverse engineer a part with a 180-degree bend. Since we'll be using a laser scanner and the part is highly reflective, we will first apply a removable white spray like MagnaFlux Spot Check SKD-S2 developer to cut down the reflectivity. To increase accuracy on the end scans, we will apply end targets to each end. These are small white poly labels that are approximately 0.004 of an inch thick. Next, we consider the position of the part for ease of measuring with the FARO arm reach. We load VTube-LASER software. Enter laser mode. Enter the part number. Rather than enter the diameter, we will measure the diameter with a laser. We connect to the arm. We're using a clamp to hold the tube, so we cancel the cut plane feature. The actual diameter is returned in the Measure a Diameter window. We'll copy this value to all the diameter fields in the part setup. You can easily modify the values to nominal in the part setup menu. Since VTube can estimate the radius, we'll use that feature to find the proper radius to use in this part. We take a series of 4 or 5 laser stripes inside the bend radius, then calculate the radius. Copy this radius to the default radius in the part setup menu. Since this part has a bend that approaches or exceeds 180 degrees, we will first set the master XYZ point count in order to allow VTube to let us choose the split bend straight. This part has 6 centerline points, including 2 for the split bend. Set the point count to 6, then enter the split bend setup window. The split bend is indicated by finding the straight number inside the split bend. In this case, use the third straight as the split bend straight. Move to the Measure Process window, then set the straight count using the Set to Master Count button. Press Multiscan and follow the instructions in the yellow box. Scan the A end of the part. Scan the first straight. VTube will draw the first cylinder with the new endpoint with a model of the scan points. Use the visual model and the cylinder fit window to determine if the scan is acceptable. Scan the second straight. For split bends, we first measure the outside apex, also known as the extra DOS. Then we measure the inside apex, also known as the intra-DOS. Then we measure straight 4. Measure straight 5. and finally perform the end measure. Here we show a close-up of the split bend model on the screen. The split bend model allows us to verify that we scanned enough points in the correct location to build an accurate split bend. We press Finish and Apply, then press Calculate New Measured Tube Data only. The blue model always represents the measured model. Now we must use the measured model to create the master. So we enter the Data Handling menu, then press the Copy Measured to Master button. We know that the intent of this part is that it has two 90-degree bends and is completely flat. So we're going to use the Reverse Calc feature to adjust the bend data and flatten the part. To do this, we switch the Split Bend feature off, then adjust the values in the LRA menu. Then we press Calc XYZ. This will calculate new XYZ data in the master tube data window. When finished making the adjustment, we press the Calc XYZ button. Then the master model XYZ coordinates will be recalculated above. But the white master model doesn't display until we switch that model on in View Control. Now we can compare the new master with the original tube by using the Recalculate Alignment in the Inspection Results menu. The white tube is the master tube. The pink tube is the measured align tube. The tolerance envelopes are either yellow or blue. Yellow indicates out of tolerance, white indicates intolerance. Next, we can print a report to email to the supplier. This report shows the XYZ centerline coordinates and the bender data. In order to show the LRA bender data in its compressed format, meaning that it shows a single 180-degree bend rather than two 90-degree bends, we can re-enable the split bend in Straight 3. Now we can save the project for use in the future. If we have a cable connection to the bender, we can enter bender setup and send setup data to the bender or send correction data to the bender. The inspection points are saved with the project, so they can be redisplayed at any time. And finally, VTube-LASER can output solid model files for use in programs like SolidWorks in the STEP format.